This video, we're going to take a look at solving systems of linear inequalities. So if you didn't watch the graphing linear inequalities, then make sure you watch that video before solving systems, because here I'm just going to focus on how to solve the actual system and look for that solution. So if you think back to graphing just linear inequalities, you graph the inequality, you look for that solution region. Solving a system, we want the solution region that are going to make both of the inequalities true. So to start off, let's just graph both of these. So this is going to be y is less than or equal to 2x, just rewriting it so I have that y equals mx plus b form. The y is already by itself, and we have a y-intercept of 0. Slope is 2 over 1, so that means we're going to go up 2 to the right 1. So up 2, right 1, up 2, right 1, up 2, right 1. Or down 2, left 1, down 2, left 1. Don't just connect it with a solid line right away. Make sure we understand if it's solid or is it dotted. In this case, it is going to be solid because it's less than or equal to. Way off. Let me try one more time. Okay, not bad. And it's going to be solid. Let's graph the next one. So I'll do this one here, x plus 3y less than or equal to 9. So I'm going to subtract x from both sides. I get 3y less than or equal to negative x plus 9. Divide by 3, get y less than or equal to negative x over 3 plus 3. So the y-intercept there is 3. Slope is negative 1 over 3. So down 1 to the right 3, down 1, right 3. Or up 1, left 3, up 1, left 3. And we want a solid line again. Not bad, not perfect. So I have my two inequalities here. And remember, we're looking at solutions. So we're either highlighting here or here or here. Like, where is that highlighted region going to fall? Because we want the only thing to be highlighted is we want the solution region that's going to make both inequalities true. So for the first one, in this first video, in this first problem, I'll highlight everything to talk about what the solution is. So the first inequality was y is less than or equal to 2x. So y is less than or equal to 2x. That is going to be, I think that was my blue line. Yeah, my blue line. I want all the values less than. And again, if you want to use a test point, you can. So the test point we could use is, let's say, like 1, 0. If I plug in 1, 0 into that, 1, 0 will give us back a true statement. So that means I'm highlighting this side. And for this first one, I'm going to highlight everything. So if I'm just looking at that blue inequality, my blue equation there, my blue inequality, that would be everything here. Let's look at the red one now. That's y is less than or equal to negative x plus 3. So that one I could use 0, 0 as a test point, which is going to be a true statement. So I'd highlight all of these values. But what I actually want is I want the overlap between the regions. So I want right here, you see where they're overlapping right in that region there? That's where both inequalities are true. So that would be my solution to the system, that one single highlighted zone. So I'm only going to highlight that zone. I'm going to go back and erase these here, and I'm only going to highlight that zone because this zone right here makes both inequalities true. That makes both inequalities true. So I'm only going to highlight that part. Now you can highlight both, but just make sure it's clear of like, this is my solution region. We typically just leave it as here is the solution region, or maybe like a different color or something. Just make sure that solution region is clear, that this area right in here is the area that's going to make this system true. All right, let's move on. So we have x minus y is less than 3, x plus 2y is greater than negative 2. So for the first inequality, I'm going to subtract x from both sides. I get negative y less than negative x plus 3. I'm going to divide by negative 1. So I get y is greater than positive x, because negative 1 divided by negative 1 is positive 1. 3 divided by negative 1 is negative 3. So I'm going to have negative 3. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And what do we want? We want a dotted line. So let's put a dotted line here. And then my other inequality is going to be subtract x from both sides. So 2y greater than negative x minus 2 divided by 2. Y is greater than negative x over 2 minus 1. So that's going to be y-intercept of negative 1, down 1 over 2, down 1 over 2, or up 1 over 2, up 1 over 2. And we want a dotted line again. So I'm just going to highlight the actual solution region. So if you look at both of them, for my blue one, y is greater than x minus 3. So that would be everything up here. Y is greater than x minus 3. So that'd be above the line. And then for my gray line here, y is greater than negative x over 2 minus 1. So that would be all of these values above that line. So greater than will be above. So it would be above the blue, above the gray. So that would make our solution region right in this part right here. That's where everything would be true, because I'm above the gray line, I'm above the blue line, so it would overlap here. And if you can't see that, just highlight both and then get a visual of like, okay, I see now where both of the overlap is happening. It is happening right here. But just to make this video a little bit cleaner, I'm only going to highlight just my solution region, which is going to be right in there. And last one, let's go ahead and graph both of these. All right, first one, negative 3x plus 4y is less than 16. I'm going to add 3x over. So I get 4y is less than 3x plus 16. Divide by 4. Y is less than 3x over 4 plus 4. So y-intercept is 4. My slope is 3 over 4. So I'm going to go up 3 over 4. Or down 3, left 4. And we want a dotted line. That's tough. Not bad. And the other one, x is greater than or equal to 2. This is just a line that's going to be vertical. So a vertical line at x is greater than or equal to 2. So that would be this line. Is it solid line? Solid line, excuse me. Not vertical or not dotted, solid line. So let's see if we can piece this together. So for the y is less than 3x over 4 plus 4, I want all the values less than that. So less than that is going to be underneath the line. Less than underneath the line. And then for x is greater than or equal to 2, I want all the values, all the x values greater than 2. So it's going to be highlighting out to the right. So we're highlighting out to the right for the blue line, the vertical line. And then we're highlighting underneath for my red line. So where does that overlap? It overlaps starting here, going out this way. So all of this region would be our solution. And same thing I said before, if you're still not able to just grasp where that solution region falls, highlight both of them and then identify it from there. And then indicate what that solution region is. But these ordered pairs in this region will make both inequalities true. So therefore, that is our solution to our system. So good set of problems there for systems of linear inequalities.